Hello, welcome to another video. Here I was reading and learning about machine learning and how to apply it by using Python, and that's why I recently check articles about it because applying machine learning methods is not enough to write an article. So you should also know how to interpret the results and how to write, so that and reading articles is quite useful to achieve that. So this article seems to be about support vector machine-based classification of schizophrenia patients and healthy controls using structural MRI imaging from two independent sites. Structural brain alterations have been repeatedly reported in schizophrenia. However, the pathophysiology of its alterations remains unclear, and multivariate pattern recognition analysis such as support vector machines can classify patients and healthy controls by detecting subtle and spatially distributed patterns of structural alterations. So they use this method to investigate it. They use independent datasets from different sites with different magnetic resonance imaging scanner protocols and clinical characteristics of the patient group to achieve a more accurate estimate of the classification performance of support vector machines. So that's why they need the many variables to test to find which one is really related. But at the same time, if they have many variables at their hand, then it is hard to analyze it, and it's hard to really distinguish which one is the right one. So that's why just basically being good at analyzing data is not enough. So they should also know which variables can be related with which one, and also they should have an explanation of it. I think it would be ridiculous if they include some variables, unrelevant variables, just because they increase the reliability or prediction rate. So that's why I think they should know how to conduct research, and also they should know how to what they're actually doing. So both support vector machine classifiers attained a classification accuracy of over 70%. The regions contributing to the classification accuracy included the bilateral medial frontal cortex, superior temporal cortex, insular occipital cortex, cerebellum, and thalamus, which have been reported to be related. So that's why they explain it's why they selected it. And the results indicated that the support vector machine could detect subtle structural brain alterations and might aid our understanding of the pathophysiology of these changes in schizophrenia, which could be one of the diagnostic findings of schizophrenia. So here in the introduction part, they must mention about general things about previous studies using this method to predict and understand the differences between patients and healthy samples. And here they mention subject characteristics of the subjects, and MRI acquisition and processing as so the machine learning classification we see. The regularization parameter for the linear support vector machine was estimated using a tenfold cross-validation approach. The trained vector machine classification performance was assessed using the following measures: accuracy, sensitivity, specificity, positive predictive value, and negative predictive value. So okay, so I think they successfully predicted based on these information. So taking together this method could help in advancing our understanding of the pathophysiology of the structural change accompanying schizophrenia, which could be one of the diagnostic findings of schizophrenia. Thanks for watching this video. I wish you enjoy and have a beautiful day. Bye bye.